Hi, you guys. Today we're going to be talking about constant rate of change. This is Chapter 3, Lesson 1. Constant rate of change is how much money you make per hour. So if you make $15 per hour, the constant rate of change is 15 for every 1 hour. If you buy cans of something at the store and you can get 5 for $1, you have $1. You're going to divide that by the number of units and you'll get 20 cents. So the unit rate is 20 cents per can. Unit rate we see all the time in things like miles per gallon, miles per hour, the speed you drive your car, things like this. These are all constant rates of change. Usually constant rate of change is telling you a story. It's telling you the change in one thing over the change in another. The change in price over the change in volume, the change in speed over time. Again, change, it tells a story about change. So you're going to be looking at constant rates of change. This is also known as the slope. Sometimes it's also called the constant of proportionality. Now, the constant of proportionality is the same thing as the slope, only if there is a constant of proportionality, and we'll talk about that in a minute. But the constant rate of change is what we're going to be focusing on, and we're going to be focusing on it in terms, again, of a linear relationship. So if you did your vocabulary like you were supposed to, you'll see that a linear relationship, and I'll write that down so you can see it, linear relationship. A linear relationship is a relationship between two variables, and it creates something very specific. It creates a line. So if you are looking at a picture of a line in a graph, you know that you're looking, if the line is straight, you know you're looking at a linear relationship because all linear relationships create lines. So to look at a linear relationship, we would take a look at something like this. So here we have a babysitter. She is babysitting for 1, 3, 5, and 7 hours. She earns $10, $30, $50, and $70 for those particular hours. To find the constant rate of change, I'm going to call it CRC because I don't want to keep writing that long phrase. You're going to find the change on the right, change, that the triangle is for delta, the Greek letter delta, and delta means change. So the change on the right over the change on the left. Okay? So the change on the right, we go from 10 to 30, that's plus 20. From 30 to 50 is also plus 20. And 50 to 70 is plus 20. You go from 1 to 3, that's plus 2. 3 to 5, plus 2. 5 to 7, plus 2. So we see we have a constant change over here and a constant change over here. Constant meaning a pattern is not changing. So our change on the right would be 20. Our change on the left would be 2. And 20 divided by 2 is 10 over 1. Now the story this is telling us is that our babysitter earns $10 per 1 hour, or $10 per hour. That's the story. Okay, now do we want to know if this is a proportional relationship? In order for it to be proportional, we're going to take away where we found the change, and we are going to see if we can create fractions that are the same. So we're going to put the left over the right. Okay, the left is 10, the right is 1. The left is 30, the right is 3. The left is 50, the right is 5. The right, I'm saying left over right, but it's actually right over left, my mistake. So right over left, so 10 over 1, 30 over 3, 50 over 5, and 70 over 7. And then we're going to look to see if each of these are equal. So 10 over 1 is 10. 30 over 3 is 10, 50 over 5 is 10, 70 over 7 is 10. So the relationship, it is proportional because each of these fractions are equal to each other, and therefore the entire thing is proportional. That's how you determine proportionality. Okay, so our constant rate of change is 10 over 1, $10 per hour. It is proportional. What's the ratio? What is the constant of proportionality? So if we were asked that, the constant of proportionality is 10 over 1. Okay, just like what we saw when we were looking at the slope and the constant of proportionality are going to be the same thing. Okay, let's try another one. What if you had something like this? Okay, so now we're talking about temperature. So we're going to look for the change on the right over the change on the left. Okay, again, I'm getting a little shorthandy. So 60 to 64 is plus 4. 64 to 68 is plus 4. 68 to 72 plus 4. 9, 10, 11, 12, these are all plus 1. So our change on the right would be 4. Our change on the left would be 1. So the right is temperature in degrees. So this would be it would be 4 degrees per hour. Oh, sorry, 4 degrees per minute. So if we are looking at a temperature change, the temperature is increasing 4 degrees every minute. Okay, so we did the change on the right, did the change on the left. We figured it out, it was 4 over 1, and that is a change in temperature over time, and that time is minutes. So 4 degrees per minute is the change. So our constant rate of change is going to be 4 over 1. Now to see if we have, and if it's proportional, we're going to make fractions. So we're going to go right over left again. So we're going to go 60 over 9, 64 over 10, 68 over 11, and 72 over 12. Now, if the first one is equal, we keep going. If it's not, then we're done. So we've got our little calculator here, and we are going to divide 60 divided by 9 equals. So this is going to be 6.66 repeating. Then we're going to go 64 divided by 10, which we don't really need a calculator for. This one is 6.4. These are not the same. Since these two are not the same, we don't need to do any more. So these are not proportional. There is a constant of proportionality? No, because they're not proportional. But they do have a constant rate of change. There is a constant change over time. It's just not proportional. Okay? Sometimes you're going to get the information horizontally instead of vertically. So we got distance traveled on a bike trip. So how far did they go in a day? So distance over time. So this would be distance over time, which means it's going to be the bottom distance over the top. So when we look for our changes, on top we can agree this is plus 1. So our change is going to be 1. 21.8 to 43.6. So we're going to clear this. We're going to say 43.6 divided by, clear, 43.6 minus 21.8. and that's going to give us 21.8. So from here to here is 21.8. 68.8 minus 43.6 equals 25.2. So from here to here is 25.2. And already we don't have a constant rate of change. Therefore, there is no constant rate of change. And we can see this already because these two aren't the same, but every one of these is the same. But you do have to be careful when you're looking at these, because if they're changing differently on top and differently on bottom, then you still have to make sure that the fractions are equal. Okay, I hope that makes sense. All right. So the other kind of way you're going to be looking for things is you're going to see things in a graph. So you might get something that looks like this. So we have this picture. Now, in order for us to figure out whether or not we have a constant rate of change, we just ask ourselves, is that a straight line? So because it is a straight line, straight lines are, they are a linear relationship. All linear relationships have a constant rate of change. Straight lines, so there is a constant rate of change. Okay, just because you know it doesn't mean you don't have to tell me what it is. So you're going to have to go back here and take a look. We're going to have to make a table because I can't. Right now, I'm not going to tell you how to figure it out. We're going to do it by a table. So our first point right here, we're going to make the horizontal be the x. So this is going to be hours. And this is going to be temperature. The temperature is 80 degrees after 0 hours. Here is another point. You see how these points aren't quite on a line, but this one is? This is our next point. That one is at 70, and we come down here, and it's at 5. Then our next one is here at 10 and at 60. So our change here is plus 10. Our change here is plus 5. So we have a change on the right, change on the left. We have 10 over 5, which equals 10 divided by 5 would be 2 over 1. What is that saying? Temp increases 2 degrees every, and this is in hours, every hour. All right? So now we have to determine whether or not it's proportional. To know if it's proportional, we're going to make fractions. 80 over 0, 70 over 5, 60 over 10. 80 divided by 0 is undefined. 70 divided by 5 is going to be, let's see, 14. 60 divided by 10 is going to be 6. These are not equal, so this is not proportional. Okay, not proportional. So the next thing we're going to do, we're going to look at one more of these graphs. So here is one that we can look at. This one is talking about book sales. And the book sales are over a matter of days. Okay, we know there is a constant rate of change because we have a straight line. We see that they've already marked points for us. So we can look at this and we're going to make a table. This is going to be day. This is going to be sales in dollars. We start here. This is 0, 0. at day 3, 1, 2, 3, 4, see they numbered every other one, so this would be 3, we had $1,000. And then here at day 6, we have $2,000. And then if we continued it up, we would see at day 9, we have $3,000. So we can see that we are going up 1,000 each time, and these are going up 0, 3, 6, 9. This is plus 3. So our constant rate of change, we've got our change on the right, our change on the left. It's going to be 1,000 divided by 3, and this is going to give us 333.33 repeating. So our constant rate of change is this. What is that telling us? That the book sales are, you're making $333.33-ish per day. That's what this is telling you. Now, is it proportional? To know if it's proportional, we're going to make some fractions. So 0 over 0 is kind of a useless thing. So we have 1,000 divided by 3, 2,000 divided by 6, and 3,000 divided by 9. So we're going to go 1,000 divided by 3. Then we got 2,000 divided by 6, 3,000 divided by 9. Notice they're all giving us the same answer. And since they're giving us the same answer, these are all equal to each other, and therefore it is proportional. What is the constant of proportionality? It would be 333.33 over 1, or per day. Now, we knew it had a constant rate of change. It's a straight line. Now, ladies and gentlemen, if you notice, this goes through 0, 0. And since it goes through 0, 0, it also tells you, without doing any math, this is proportional. Anything that goes through 0, 0 is proportional. So let me have you look at these two graphs one more time. So we had this one, and then we had this one. This one was not proportional, but this one was proportional. Okay? This one goes through the origin. This one started at 80. This one is y equals mx. This one is y equals mx plus b. The difference between proportional and not proportional is what's after x. If there's nothing after x, it goes through the origin. If there's something after x, it doesn't. Okay? Proportional and not. All right. That's the end of the first lesson. Good luck with your homework.